Hey guys, here are notes for 7.2 vectors on a coordinate plane. So we've been talking about distances and distance formula. Let's talk about vectors on a coordinate plane. And you may have heard the word vector before. If you've ever seen the movie Despicable Me, Vector was the villain. So let me show you a quick video of Vector. We'll see if it plays. There's an ad first. We got to skip the ad. But let's see. Alright, here we go. Enjoy the video.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Doing a demonstration. Oh! Ah! It's so difficult sometimes to get the blade back inside. Woo!
Mr. Groove, Mr. Perkins will see now.
Look at you, a little tiny toilet for little tiny baby. Ah! Curse you, tiny toilet! Girls, welcome back to the fortress of Vectortude. You have my cookies for me? Exactly. I'd like to see somebody else order that many cookies. Not likely. Name one person who ordered more cookies than me.
Are you wearing pajamas?
These aren't pajamas. This is a warm-up suit.
What are you warming up for?
Stuff.
What sort of stuff?
Super cool stuff you wouldn't understand.
Like sleeping?
They are not pajamas!
Please don't let me, I'm gonna die! Please don't let me!
Squid lobster! Oh yeah! Don't worry. The moon is as good as ours. Oh yeah! Oh yeah! Once again, a mighty...
Mr. Groove!
Zip it, Happy Meal. No! Oh yeah! Unpredictable! Oh, poop.
Alright, just wanted to give you a little preview of a vector, what a vector is. And he even said it, it's a mathematical term. So a vector can represent any physical quantity that has both direction and magnitude. Exactly what he was talking about, committing crimes with direction and magnitude. A vector represents a change in position. If a car travels from stop sign A to stop sign B, the vector is AB, or written as AB with a half arrow. A half arrow is the symbol for vector. The initial point is where the vector begins, and the terminal point is where it ends. It's just like looking at a ray. And it's a ray goes in one direction, has an initial point, and the terminal point is on a vector, because a vector is actually stop. You go their direction. The change in x would be from a 2 minus a negative 3. That's going to be a 5. The change in y would be from a 3 down to negative 2 where it started, which would be a 5. So the vector would be 5, 5, or they sometimes use these less than and greater than signs, would be 5, 5. But this is called the component form of a vector. So we call it component form. Sometimes looks like a coordinate, or it could be in the less than and greater than symbols. Moving on. Okay, naming vectors. To name a vector, find the change in the x-coordinates and the change in the y-coordinates. Little triangle. Triangle x, comma, triangle y means change in x and change in y. So how much the x changed and how much the y changed. So you always go to your terminal point and subtract your initial point from it to see how much it changed, because it went from this initial point to the terminal point. So you subtract them and you can see how much it changed. So if you're looking at for AB here, for vector AB, you would find the change in x, which is the 2 minus the negative 4, which is a 6. The change in x means it went over 6, which you can see right here. 2 minus negative 4 is 6. So you went over 1, 2, 3, 4, 5, 6. That's how much the x changed. It went from negative 4 all the way over to 2. And then the change in y would be from 2 to negative, from a negative 4 down to a positive 2. So we go 2 minus 4, and that means it went down 2. So you went over 6 and you went down 2. That would be your vector. And the vector here would be 6, negative 2. So let me write that down here. The vector would be 6 and a negative 2. That would be the vector for this one. A vector is moving from point A to point B. Therefore, the change must be x2 minus x1 and y2 minus y1. That's what we did up here. Okay, a practice problem. If a robot moved from point C, which is 16, negative 6, to point D, 9, negative 6, then what would represent the displacement vector or the movement vector, how far it moved, for the robot's movement? So the vector, you would do the change in x. So it went to number 9 and it went from 16. So you do 9 minus 16. That's going to be a negative 7 move. It means it's going to be to the left 7. And then the change in y would be from a negative 6 minus another negative 6. So you're actually going to get 0 there. It doesn't change. The y's don't change at all. It just went straight across, over. And that vector would be a negative 7, 0 vector. So it would go over 7 negative, and it would stay on a horizontal line. So that would be the vector negative 7, 0 for this little practice problem. Here's an example. If vector u is negative 3, 2, it has an initial point of 4, 9. So it's starting at 4, 9. It's going to go over negative 3 and up 2. To the left negative 3 and up 2. Where is it going to end? If this goes to the left negative 3 and up 2, where is this terminal point going to be? So the initial point was 4. You add your vector to it, so you add the negative 3, and then you're going to end up at 1. So if you start at 4 and you go to the left 3, you're going to end at 1 there on the x-axis. The initial point for the y is a 9. You're adding 2 because you're going up 2. So you're starting at 9 and you're going up 2 more, so you're going to end up at 11. So the terminal point would be the point 111. It would start at 4, 9 and it would end up at 111. That means it would have a vector of negative 3, 2. It would have gone over negative 3 and it would have gone up 2. You could graph that, start with this point, end up with this point, and you could see that the vector would be over negative 3 and up 2. Now magnitude is another thing that Vector City had, was magnitude. We know that direction is the naming them. The magnitude of a vector is the length of the segment representing the vector. Since length is always positive, we can write the magnitude of vector AB as the absolute value of AB, because the absolute value is going to make everything positive. So in other words, you can use the distance formula to find the magnitude of a vector. The distance formula gets us length. Tells us how far something is. So here's our distance formula. The change in x squared plus the change in y squared. So your vector distance would be the change in x squared plus the change in y squared. That would be your vector distance. All right, example. Find the magnitude of the vector with an initial point of 0, 0 and a terminal point of 5, 4. We'll find the magnitude. So what we want to do here is use our distance formula or our magnitude formula for a vector. We're going to do the change in x, so 5 minus 0 squared, and the change in y would be 4 minus 0 squared. So that's going to be 5 squared plus 4 squared, which is 25 plus 16, which is radical 41, which is just approximately 6.4 when you round it off. So magnitude is distance formula. What if we knew the vector though? What if we want to find the magnitude of a vector AB with a component form of negative 4, 3? So we already know that the change in x is negative 4 and the change in y is a 3. That makes it even easier because we can just go straight to the change in x, which is negative 4 squared. This is how much the x changed, so square it. This is how much the y changed, so square it. You're going to get 16 plus 9, and you're going to get 25, or square root of 25, which would equal a length of 5, or a magnitude of 5. So if you've got the vector already, to get the magnitude is very easy. You just square the x, the change in x, and you square the change in y, and you have your vector magnitude. All right, what about a resultant vector? Result is the word that's in there. Result is a resultant vector is the result of adding two vectors together. If we were to add vector AB plus vector BC, if we added AB plus BC, we would end up with the vector AC. So we would go, so instead of going from A to B and B to C, we'd go straight from A to C. So if we add this one plus this one, you're going to get this vector right here. Let's take a look at how that works. First, let's find the vector from A to B. From A to B, we go over 9, and you go up 1. So 9 minus 0 and 1 minus 0 would means we go over 9 and we go up 1. From this point to this point. Vector BC is from right here. So you're going to get to from point B over to point C, you're going to go over 7 and you're going to go down 7. Oops. So over 7 and down 7. That would be over 7, down 7. So from here, 16 minus 9 would be 7. From here, negative 6 and minus 1 would be a negative 7. So you went over 7, you went down 7. Now if I want to add these two vectors together, vector AB plus vector BC, I would add my two x coordinates. My 9 and my 7 were my two x coordinates. I would add my two y coordinates. Whoops, and I messed up on that, so let me fix that. This would be a negative 7. So I would add 1 plus negative 7. That would give me my negative 6. And I'd add 9 plus 7. That would give me my 16. So my addition of these two vectors together, if I added these two vectors, I would get the vector 16, negative 6. And you can check the graph. If I go over 16 and down 6, then I am at point C. That is vector AC right there. So that is vector AC. I should put the little vector symbol there. And probably put the vector symbols here. Because we are adding these two vectors together. So that would be it right there. Alright, one last example. We've got Lisa and Greg are moving a tool cabinet on rollers. The forces they apply to the cabinet are represented by the vectors P, which means that it's going over negative 2 and down 5. So over negative 2, down 5. Vector Q, which is going over 1 and down 4. Positive 1, down 4. Find the resultant vector of adding those two together. So we need to add the two x's and we need to add the two y's together. So you would get negative 2 plus 1, which is going to be vector r. When we add these two together, we get vector r. we're going to and add -5 plus -4. Those are the two y values. So your two x values come out as -1. Your two y values come out as -9. So when you add these two vectors together, your new vector is -1, -9. That is your notes for section 7.2. I'll see you guys later.